More commonly, I'm referred to as Vader for many reasons. So that's why I have to hide the background, because you're not supposed to know what Vader's lair looks like. And no, this is not the most efficient chroma key, but it works, and there's lots of things that we have to do that are not necessarily optimum. So let's get into the fun here, and let's take a look at what we're going to be working in. So TinkerCad is a really helpful software. It's one that I use very heavily. What you're going to want to do is set up an account with them. It's tinkercad.com. You'll start off something like a home page with drawing examples and some other things. I haven't spent tons of time doing big projects in this because I use SolidWorks for other big projects. There have been a bunch of things that we design in TinkerCad specifically for the UNV 112 class, but things are going to be a little different this semester. So where you're going to want to spend your time is over here in circuits. And what this will allow us to do is all sorts and types of different things. I recommend, if you haven't done anything on their site before you create a new circuit, there'll be some tutorials here. If you don't see that and you already have something started, you can delete some of the other circuits, and then it'll bring this window back where you can go back to their tutorials. Then once you've gone through those, you'll actually do kind of one of the examples. The reason that I started there is one of the examples they go through is more or less how to put together a simple flashlight, but we give them some additional criteria to figure out how we can make it brighter. Can we use bulbs and a bunch of these other things? So this is going to be focused on lab 3, and that's where we're going to spend our time. So the idea is my daughter has decided there's monsters everywhere, and the monsters are always coming, and so we need a flashlight, and we need to build it out of scrap electronics. So how do we do that and teach in the context of teaching how to set up basic circuits for this? The simplest version of a circuit is starting from a blank sheet, having some kind of a battery, coin battery or a AA. We're starting out in the basic components. Later on, we'll be using the all component list to do some much more fancy things. We'll also be programming Arduinos and things, so we'll start getting into code in some of the other ones. But for this particular video, we're not going to need any of that. A bunch of basic, just kind of simple operations things. If you've never used this software before, you can zoom in and out. This is a quick zoom to fit for all the components that you have. If you move stuff around and don't know where you got lost at, you can always come back up here and hit the zoom to fit to recenter yourself, because you can actually build some fairly large components with multiple connected systems and simulate it in this. When you click a component, when you left click a component, you can rotate them. It does, like, what are they, 30-degree rotations or something like that. So they're not quite 45s, but they will allow you to get some different orientations of parts. That's really helpful once you start going to build bigger and bigger circuits. So we start off with something simple like a battery. If we want to get really fancy, we can do a push button switch or a slide switch. Most flashlights have some kind of a slide switch. So you go here, you grab the components, and it'll tell you with this little highlighted box what each of these pins are on different things, including for displays and other stuff. There's breadboards, there's an Uno R3. This is part of the kit that we're actually sending out to the students, and you can develop all of the code that's going to run on the Arduino R3 that you can then drop right into the Arduino software and load onto a board. And so we're going to show some examples, and I have to make sure that I've actually built the physical circuit and make sure that you guys have the ability to work not only in this circumstance but also in some other circumstances as well. So a bunch of different things that we're going to get into later on in the semester, even fancy RGB flashlight. You could do all sorts of things depending on your particular comfort level, how much time you've spent on this. You can even design a flashlight that, using a photoresistor here, will only turn on if the light level is low, and there's all sorts of other things you can do there as well. So what we're going to do first is just a simple example. This is very similar to what they have in a normal flashlight. So each time you click a component, it'll give you a name. You can name it something else. You can call the battery Fred if you really want to. I don't know what that benefits you, but sometimes you want to make sure that you name specific components. If it's, hey, I need to know if I'm using 2 different voltage supplies, I use battery 1, battery 2, or whatever. When you're building more complicated systems than this, it's helpful to have some examples. You'll also note that you can change the colors of these LEDs. And so probably you don't want a red flashlight or a blue flashlight. You probably want a white LED. They don't really simulate different light levels from LEDs in here, but that's not really the goal of the whole thing. So switch. This is an example. Usually this is somewhere like on the side. So I'm going to go ahead and rotate this guy. This is usually somewhere like on the side of your flashlight. And this is something that you can help kind of keep track of things. So when you want to add a wire, you click on one of the terminals, and then it'll give you some alignment lines that'll show up. So one of the things that I like to do is give myself a couple corners. So you click once or twice, and then we can make a connection to, in this case, I'm going to run a common ground, this, so that you can see what happens. You can also change the color of these wires. Since this one's a ground, I'll go ahead and switch this one to black, and I'll switch this one to red since it's positive. But if any of you have worked with LEDs in the past, I guess I'll do that one orange since that one's a hookup wire. Once we put the circuit together, we can hit start simulation, and right now nothing happens. We flip the switch and nothing happens. It won't give any kind of a warning message, but it shows you the longer leg of the LED, the anode. This is because this should be positive. Well, if you try and run a diode backwards, it doesn't work and doesn't work and doesn't work. Then it lets the smoke out, and then it works, but it doesn't actually work the way you intended. So don't do that. So we can then delete this wire just by clicking and hitting delete. We can relocate this wire here to the anode where it belongs. And we remember the easiest way to remember where the cathode goes is cats are bad, so cats go on the negative side. So we bring the negative over here, and this now becomes a ground wire. And if we simulate it, the light comes on. But you'll also notice that you get a little warning that tells the students, hey, while yes, you've made a flashlight, really these are recommended for 20 milliamps, and right now this is running 60 milliamps. So it'll be really bright until it's not anymore.